So now it's finally time to introduce this new rule that's going to make solving limits a lot simpler in some cases. All right, so this rule is called L'Hopital's rule. So L'Hopital's. All right, L'Hopital's rule, and it says this. So I'm trying to figure out this limit of this fraction. All right, so I'm trying to do this limit here. And what happens if I try to just plug in my a value? I get 0 on the top and 0 on the bottom. So it's basically saying if I try to plug in a, I get 0 on the top and 0 on the bottom. All right, what L'Hopital's rule allows me to do, so this is the step here where they're doing L'Hopital's rule, so I'll just abbreviate it like that. All right, so L'Hopital's rule says if I get this 0 over 0, what I can do is I can take the derivative of the top and I can take the derivative of the bottom and then retry the limit. All right, so whenever you're doing a limit and you get 0 over 0, you take derivatives and then retry your limit. All right, so let's see this in practice. Again, the first thing you should always do with a limit is just try to plug in the number. So if I try to plug in a number, cosine of 0 is 1, and I get 0 over 0. All right, so this is the first thing to check. This is really important that you get 0 over 0, because if you do get 0 over 0, then I can use L'Hopital's rule, and I get the same limit. The limit's still going to 0, but now, instead of 1 minus cosine of x, I take its derivative. All right, the derivative of 1 minus cosine of x is going to be positive sine of x. The derivative of x is 1. And now I did L'Hopital's rule. I try to plug in 0 again. When I try to plug in 0 again, I get sine of 0 over 1. Sine of 0 is 0. But 0 over 1, that's actually fine. That is just 0. So that's my final answer for this limit. I get 0. All right, so this is the way L'Hopital's rule works. All right, if you're doing a limit and you get 0 over 0, then you take derivatives. All right, one semi-confusing thing is with L'Hopital's rule, you just take the derivative of the top and it stays on the top, and you just take the derivative of the bottom and it stays on the bottom. You don't have to do the quotient rule because you're not taking the derivative of this whole fraction. You're just taking the derivative of the top and it's staying there, and you're just taking the derivative on the bottom. All right, so getting L'Hopital's rule and the quotient rule mixed up is a common thing. All right, but one involves limits, and the other one's just taking the derivative of a function all by itself. All right, so another example, plugging in 0, all right, because our limit's at 0, so that's the first thing we're going to do. Sine of 0 minus 0 over 0 squared. Sine of 0 is 0, and you get 0 over 0 again. All right, that's always important to check. All right, and then because I get 0 over 0, I can do L'Hopital's rule. All right, the limit's going to stay the same. But now the top of my function, I take its derivative. Sine turns into cosine. Minus x turns into minus 1 over 2x. And now I try to plug in 0 again after I do L'Hopital's rule. Cosine of 0 is 1. 2 times 0 is 0. And I get 0 over 0. So I get 0 over 0 again, which means now I have to do L'Hopital's rule again. So I just keep doing it until I don't get 0 over 0 anymore. My derivative of cosine is negative sine. Derivative of 2x is 2. And now I plug in 0 into that. And sine of 0 is 0. So my final answer is 0. All right, so L'Hopital's rule, every single time you get 0 over 0 when you're attempting a limit, you take the derivative of the top, you take the derivative of the bottom, and then you retry your limit. You retry to plug in that number.